Hello guys, welcome back to my YouTube channel. So today we are going to solve day 21 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2872, maximum number of K divisible components. Okay, so this problem is marked hard by Leetcode. Okay, so let's read the problem statement first. There is an undirected tree with n nodes labeled from 0 to n minus 1. Okay, so n is equal to 5. So simply means that we have nodes from 0 to 4. Okay, 0 to 4 we have nodes, right? You are given the integer n and a 2D integer array edges of length n minus 1. Okay, so n is 5. Okay, so we have 4 edges, 1 2 3 4. Okay, you are given the integer n and a 2D integer array edges of length n minus 1, where edges of I, A to B indicates that there is an edge between node A and B in the tree. Okay, so 0 to 2 there is one edge, right? 0 to 2 there is one edge. 1 to 2 there is one edge. Okay, 1 to 3 there is an edge, right? And 2 to 4 there is an edge. All right. Okay, so you are also given a 0 indexed integer array values of length n, where values of I is the value associated with the ith node and an integer k. Okay, so this is values array given to us. Okay, and this is the value of 0th node, this is the value of first node, this is the value of second node, this is the value of third node, this is the value of a fourth node. Okay, so let me just write it here. So 0th node value is 1. Okay, so here I'm writing the values. Okay, node 1 value is 8. Okay, so node 1, this is my node 1, so value is 8. Okay, node 2 value is 1. Okay, and node 3 value is 4, and node 4 value is also 4. Okay, this is 4. All right, and this is 1. Okay, all right. A valid split of the tree is obtained by removing any set of edges, okay, possibly empty, from the tree such that the resulting components all have values that are divisible by k. Okay, where the value of a connected component is the sum of the values of its node. All right, we have to return the maximum number of components in any valid split. Okay, so understand this line. A valid split of the tree is obtained by removing any set of edges, possibly empty, from the tree such that the resulting components all have the values that are divisible by k. Okay, resulting components. So here see, if I just split this tree like this, so here this node value is 8, this value is 4. Okay, and here this value is 1 4 and 1. Okay, so we have two components here. Okay, let's say this is my component 1 and component 2. Okay, and the value is 6. Okay, so here sum of these two, 8 for 12, so 12 is perfectly divisible by 6. Okay, we get a remainder as 0. Okay, and here sum is 4, 1 plus 1 5, 5 plus 1 6, 6 is completely divisible by 6, so remainder is 0. Okay, so this is the meaning of this one, right? Resulting components all have values that are divisible by k, where the value of a connected component, okay, connected component is the sum of the value of its nodes. Okay, all right. So here one more thing, see this constraint. Okay, this is important. Sum of values is divisible by k. Okay, sum of values is divisible by k. So all these values, okay, if we do the summation of all these values, 8 plus 1 9, 9 plus 1 10, 10 plus 4 14, 14 plus 4 18. Okay, so this is always going to be divisible by our k value. Okay, all right. So here if I'm dividing the components, okay, so here let's say I picked one part. Okay, 8 for 12 part I pick, so remaining part also it's going to be divisible by k. Okay, if this component is divisible by 6, then definitely this remaining component will also be divisible by 6. Okay, so that's the simple meaning. Okay, so here see, because we know that summation of all these values is always going to be divisible by 6. Okay, so if I am picking any one component which is completely divisible by 6, okay, then definitely the remaining component will always be divisible by 6. Okay, so see now here, uh see 6 is there. Okay, so here I have 54 is divisible by 6. Okay, 54 is completely divisible by 6. Okay, and then from this 54, let's say I pick one part, I pick 24 because 24 is divisible by 6. Then the remaining part is going to be 30. Then 30 is also going to be divisible by 6 now, right? This is great, simple mathematics, right? If one part is divisible by 6, then definitely other part is always going to be divisible by 6. Okay, so this is what we need to do. Okay, and we have to turn the maximum number of components in any valid split. Okay, so I hope that you guys are clear with the problem statement. Okay, so now how we are going to solve this problem. Okay, so let's understand that. All right, so here let's do one thing. Let's create this tree, okay, by treating this 0 as my root node. Okay, so here let me write it like this. So first I'm writing 0. Okay, and 0 is connected with 2. Okay, so here this is 0 and I'm saying that 0 is connected with 2. Okay, let's draw it like this. 0 is connected with 2. Okay, and 2 is connected with 4 and 1. Okay, 2 is connected with 4. Okay, and 1. Okay, all right, and 1 is connected with 3. Okay, so let's say 1 is connected with 3. All right, so I have created this tree starting from 0. Okay, I'm going to read it like this. Okay, and now let me write the values. So for 0 value is 1. Okay, let me write it with some other pen. For 0 value is 1. Okay, for 2 value is 1. All right, for value is 4. Okay, and for 1 value is 8. Okay, and for 3 value is 4. Okay, all right, so now I'm going to start from here. Okay, so first take this. Okay, so first how you are going to write the code. So first this is a simple graph, right? So I'm going to create one adjacency list. Okay, so here adjacency list, so we have nodes from 0 to 4. Okay, so 0 is one node. Okay, this here I'm writing node. Okay, node. Okay, 0 node, we have one node, we have two node, we have node 3. Okay, we have node 4. Okay, all these nodes we have. All right, okay, so first you are just going to create one adjacency list like this. Okay, so now here 0 is connected with 2, right? 0 is connected with 2. Okay, so here I'm going to write 2, and 2 is also connected with 0, right? I can write 0 here. 0 is connected with 2, 2 is also connected with 0 no? So here I'm writing 0. Okay, node 1 is connected with 2 and 3. Okay, so here I'm writing 2 and 3. Okay, and 2 is also connected with 1 and 4. Okay, 3 is connected with only 1. Okay, and 4 is connected with 2. Okay, so I can write like this, right? These are the nodes and these are nothing but the nodes which are connected. Okay, there is one edge 0 to 2. Okay, there is one edge from 1 to 2, 1 to 3, right? There is edge from 2 to 0, 2 to 1, 2 to 4. Okay, this is clear, right? Nodes. Okay, and this node we are just populating the adjacency list with the edges. Okay, so these are the edges. Okay, so 0 for 2. Okay, so this is done, and then I'm just going to call the DFS. Okay, so DFS, what I'm going to search. Okay, I'm going to search that if any particular leaf node, okay, if any particular leaf, okay, if any particular leaf is completely divisible by my k, okay, then I'm just going to separate that component. Okay, so here let's say okay, so here first do one thing. First I'm going to start from here. I'm going to call one DFS method. Okay, so I'm going to solve this problem using the DFS. Okay, in this part, in this video. And if you guys need the solution in BFS, then please write it in comment. I will also make a separate video for BFS. Okay, otherwise this video is going to become very lengthy. Okay, so that is why in this video I'm going to solve this problem using simple DFS. Okay, so here I'm going to call DFS. Okay, and from 0 I move to this side. Okay, I move to this side. Okay, let me use some other pencil. So from 0 I move to this side. Okay, okay, so 0 I was at node 0. Okay, and I was at node 0, and node 0 has only one children. Okay, 2. Okay, so here I move to node 2. Okay, from node 0 I move to node 2. Okay, all right, neighbor 2 is the neighbor of this 0. Okay, so here node 0, node 0, I move to this node 2. Okay, and now check for node 2. Okay, so for node 2 we have one neighbor, this. Okay, 4. Okay, so I move to node 4. Node 2 has one neighbor 1 and one neighbor 4. Okay, so here let's move to the 4. Okay, or you can say let's move to 1 first. Okay, I'm writing it like this now, 0 1 4. Okay, in like this, in this order. So I'm not going to move to the parent. Okay, I'm not going to move to parent. Okay, this doesn't make sense. 0 to 2 and again 2 to 0. Okay, this doesn't make sense. So from node 2, instead of moving to 0, I'm moving to 1. Okay, so here I move to, let's say here, node 1. All right, node 1. Okay, and from node 1, if you see, uh, from node 1, I can move to node 3. Okay, I can't move to node 2 because this 2 is parent now. This 2 is parent, so this doesn't make sense that from 2 I'm moving to 1 and again from 1 I'm moving back to 2. Okay, this doesn't make any sense. So from node 1 I move to node 3. Okay, node 3. Okay, understand it carefully. Okay, node 3 I move. All right, so this node 3 doesn't have any child. Okay, this node 3 doesn't have any child. This one is parent for this. Okay, this one which is neighbor of 3 is a parent. Okay, so I'm not going to visit the parent for this. Okay, so this doesn't have any child. Okay, all right, so now node 3, what is the value we have at node 3? Okay, so here see carefully, what is the value we have at node 3? So at node 3 we have value 4. Okay, we have value 4. All right, so this 4, is it completely divisible by 6? No, 4 is not completely divisible by 6, right? It's not divisible by 6. Okay, this 4, so I can't just separate it out. Okay, I can't do that, right? This 3 doesn't remain, this 3 is not going to be my separate component. Okay, because here sum is 4 and 4 is not completely divisible by my k. Okay, so now I move back. Okay, so node 1, I move to node 1. So here sum is 8, so here it's 8 and here previously it was 4. Okay, so I'm going to do the summation of these. So what is the sum I'm going to get? 8 plus 4, 12. Okay, so 12 is completely divisible by my k. Okay, so if it is completely divisible by k, right, which is 6. Okay, so I'm going to separate it out. Okay, I'm going to separate it out. Okay, I'm going to separate it out. Okay, so here I can do one more thing here. Okay, so here sum was 4 now. Okay, so if I'm doing the 4 modulus with 6, what is the result I'm going to get? This is nothing but my remainder now. 4 modulus with 6, I'm going to get 4 only. Okay, remainder is still 4. I didn't get the perfect answer. Now here I do the summation of this 8 and 4. Okay, so I will get 12. So if I do the 12 modulus with 6, I get the summation as 0. Okay, so in this complete part, my sum is 0. Okay, my the modulus which I took. Okay, so it becomes 0. Okay, my sum becomes 0. How my sum becomes 0? 8 plus 4, 12, and I did the modulus with 6. Okay, so it becomes 0. Okay, so if it becomes 0, then increment the count of components. Okay, increment the count of components to 1. Okay, this is one component. All right, now after that I move to this node 2. Okay, this node 2. So this node 2 has two children. Okay, 4 is also there now. Node 2, 4 is also there. Okay, so here for this node 2 we have one node 4 as well. Okay, node 4. Okay, and node 4 doesn't have any child. Okay, we can't move back to the parents. Okay, so node 4, what is the value we have? 4. Okay, node 4 we have 4 value. Okay, this is done. Now I can't take this 4 separately. Okay, I can't take this 4 separately because 4 is not completely divisible by 6. Okay, so from here what is the remainder I'm getting? 4 modulus with 6, I'm getting the remainder as 4 only, right? This is the remainder I'm getting. Okay, so move back. Okay, move back. So I move to the node 2. Okay, so now here at 2, what is the values we have? This is 4 and this is 1. Okay, so 4 plus 1. Okay, and it is nothing but 5. Okay, 5 is divisible by 6? No, so I can't take this component as well. Okay, this doesn't make any sense. All right, now I move back to node 0. Okay, move back to node 0. Okay, simple recursion. So I move back to this one. Okay, so now 5 plus this 0 node value is 1. Okay, 5 plus 1 is 6. So 6 is completely divisible by 6. Okay, so my sum becomes 0. Okay, I'm doing the modulus with k, right? And then I'm updating my sum. So my complete sum becomes 0. Okay, so now in this part, my sum becomes 0, right? So I'm going to increment my comp count to 2. Okay, components count to 2, right? And done. That's it. Okay, so here output is 2. Okay, so I hope that you guys are clear with DFS approach, and same thing we need to do here. All right, so here 7 and 7 simply means that we have 6 edges, 1 2 3 4 5 6. Okay, and these are the values. So here if I write the values, so it is going to like this: 3 0 6, okay, and then 1 5 2 and 1. Okay, and k is 3. Okay, so here now how we are separating this. Okay, so node 3. Okay, so create one adjacency list. Okay, let me just write now for your understanding: 0 1 2 3 4 5 and 6. Okay, and 0 is connected with 1 and 2. Okay, 0 is connected with 1 and 2. Okay, 1 is connected with 0 3 and 4. Okay, 1 is connected with 0 3 and 4. Okay, and 2 is connected with uh, 0 5 and 6. Okay, 0 5 and 6. This is the first thing that we need to do. Okay, and 3 is connected with 1, 4 is connected with 1, 5 is connected with 2, and 6 is connected with 2. Okay, so again start from 0. Again start from here, call the DFS. All right, so first 0's neighbor is, I am at node 0. Okay, node 0, and 0's neighbor is node 1. Okay, I go to node 1. Okay, I move to node 1. All right, I move here. So now node 1, again node 1 has more neighbors. Okay, node 1 has 3 and 4. Okay, so I move to node 3. All right, so node 3, here I move to node 3, and node 3 doesn't have any children. Okay, any further children. Okay, so what is the value at node 3? So value at node 3 is okay, so value at node 3 is 1. Okay, so 1 is the value I'm getting. Okay, and 1 is completely divisible by this k? No. Okay, so here I'm going to update it like this now: 1 modulus with 3. Okay, it is still going to give me 1 only, right? This is how I'm checking the sum. Okay, and this is not divisible by, my sum doesn't become 0. Okay, right now. So now node 1 has one more neighbor. Okay, node 1 has one more neighbor, 4. Okay, so node 1 has one more neighbor. I visited this 3. This has one more neighbor. Okay, so I move to node 4. Node 4. All right, so node 4 has value 5. Okay, and doesn't have any children. Value is 5. I took this 5 in consideration. Okay, 5 into consideration, and 5 modulus with k I did. So my k is 3 now, so 5 modulus with 3, so I will get my output as 2. Okay, 5 modulus with 3, 3 1. Okay, 3, and here I'm getting the remainder as 2. All right, so here I'm writing 2. Okay, so still it doesn't make any sense. Okay, I can't separate it out. Okay, now we have to take this complete component, right? This is going to be my next step. All right, so here what is the value at node 1? So node 1 value is 0. Okay, so this node 1 value is 0. Okay, so now here node 1 value is 0. Okay, so here we have to do the summation now. So this complete part we are taking now. So what is the sum for this part? So node 1 value is 0. Okay, and node 3 value is coming out as 1. Okay, so here I'm writing 1, and node 4 value is coming out as 2. Okay, so here I'm writing 2. So 0 plus 1 plus 2 is going to be 3, and 3 modulus with 3 is going to give me 0. Okay, 0. So this is going to my one component. Okay, so that is fine now. See here, this is one component. I separate it out because here sum becomes 0. Okay, sum becomes 0. 3 modulus with 3 I get 0. Okay, sum becomes 0. All right, so this is done. Okay, now after that node 0. Okay, so I have completed this part. Node 0, I move to node 1. For node 1 I check the neighbors. So node 1 has neighbor, node 3 and node 4. Node 3 check neighbors, nothing is there. Node 4 I check the neighbor, nothing is there. I check whether I can separate out this node 3 or I can separate node 4. I can't separate both of them. Then I do the summation of the children with their parent. Okay, and then if when I did the summation I find out that sum becomes 0. So if my sum becomes 0 in that case, then I have incremented the count of my components. Okay, so component count will become 1 right now. All right, so now node 0 is also connected with node 2. Okay, so from here I go to node 2. Okay, 0 to 2. Okay, so node 2, same thing I have to do now. Okay, node 2 I move, then I am going to check the neighbor of. Okay, so here I am going to get output as 2. Here I am going to get the output as 6. Okay, so here see, node 2 I move. Okay, and node 2, after node 2 I'm going to move. Node 2 has neighbors 5 and 6. Okay, I'm not going to move back to the neighbor. Okay, a parent. Okay, so here node 5, node 5. All right, so node 5. So here node 5, what is the value I'm going to get? 5 modulus with 3. Okay, so 5 modulus with 3 I'm going to get 2. Okay, 5 modulus with 3 I'm going to get 2 here. This node 5 value is 1 second. 0 1 2 3 4 5. Okay, this value is 2 now. This value is 2, sorry. So okay, this value is 2 and this value is 1. Okay, so here again you see this value is 2 and this value is 1. Okay, 1 second. 0 1 2 3 4 5. 5 is 2 and 6 is 1. Okay, and 2 is, this 2 is 0 1 2 6. Okay, 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 so this part. Okay, so here value is 2 now. 2 is not makes sense. Okay, 2 modulus with 3 I will get 2 only, and here 1 modulus with 3 I will get 1 only. Okay, so this doesn't make any sense. I'm not going to separate it out. Okay, so 2 plus 1 plus 6, so I'm going to get overall sum as 9. Okay, 9 modulus with 3 I will do, I will get 0 as total sum. Okay, so in this part also my sum becomes 0. Okay, summation of all of them, and then modulus with k. Okay, so I will get 0. All right, so I separate it out. Then definitely the remaining part is going to be this was the only node left. Okay, only one node left, so just come out of the loop. Okay, and return the output. Okay, so for this one also sum is 3 and 3 modulus with 3 is 0. Okay, and increment the count of comp, so 1 2 and then it will become 3. All right, and then we have to just return the answer. Okay, so this is what we need to do. Okay, so now let's write the code. Okay, so let's write the code. All right, so these are the constants given to us. Okay, so let's solve this problem using DFS. All right, so first, what is the first thing that you have to do? First you have to initialize the adjacency list. All right, so here write list. Okay, I'm going to create a list. Okay, and my list is going to have integer. Okay, array. Okay, and let's name it as adjacency list, and here new array list. Okay, and the size is going to be n. Okay, 0 to n minus 1 we have to give, so size is n. Okay, because 0 is also there. All right, now just iterate over all the nodes we have. Okay, int I is equal to 0, I is less than n, I plus plus. Okay, and let's initialize all the lists we have. Okay, so here I'm going to initialize all the lists. Okay, list this 0, list this list, this list. Okay, I'm just going to initialize it. Okay, so here I'm going to write adjacency list. Okay, of I is equal to new array list. Okay, then we have to prepare the adjacency list with the edges. Okay, so simple for each loop, iterate over all the edges we have. Okay, and here inside this take u as edge of 0. Okay, a and b, you can take a and b as per question. Okay, so here edge of 0, int v. Okay, as edge of 1. Okay, This is what I'm saying. Okay, A and B. So instead of you can take A. Okay, instead of V you can take B. But in the past also, whenever we have solved the questions using this approach now, so we have used U and V only. Okay, that is why I'm using U and V as variables. You can use anything, no issues. Okay, adjacency list. Okay, so in adjacency list U, okay, I'm going to add V. Okay, all right, and then in the adjacency list, okay, V, I'm going to add U. Okay, so this is what we have to do here, right? And then we have to create one array to count the number of components. Okay, so int component count. Okay, new int size is 1 only. Okay, we have to just keep the count, okay, with us. So because I'm going to call the DFS, so we have to keep the count like this only. Okay, because this is going to help us in the store the value, okay, latest value inside it. So here I'm going to call the DFS. Okay, so in DFS, but I'm going to pass. So initially I'm going to start from my current node, which is 0. Okay, so I told you that we are going to start from from our root, and we are going to take the root as 0. Okay, in the starting. So 0 doesn't have any parent. Okay, so now I'm going to add the parent. So 0 doesn't have any parent, so I'm writing -1. Okay, and then just pass the adjacency list that we have. Adjacency list we have, then pass the values. Okay, all the values, then pass the value of K, and then pass the component count. All right, array, this component count array. All right, and here, from here, I'm just going to simply return component count at 0 index. Okay, only one index we have, so here we are just going to store the count. All right, now just define this DFS and that's it. So private int DFS. Okay, so this DFS method is going to return me the count. Okay, so here what we are passing, we are passing the current node, which is 0. We are passing the parent node. Okay, parent node, and we are passing the adjacency list. Okay, so let me just copy this line, and what we are passing values. So let me just copy this line, and what we are passing K, so I can copy this, and we are passing component count, so let me just copy this. Okay, so this is done. All right, so now here initially take my sum as 0. Okay, and then we have to iterate over all the neighbors, okay, in my adjacency list. So for int neighbor node, okay, in the adjacency list, okay, current node, okay. So I'm just going to check the neighbors of my current node. Okay, 0 right now. So only if my neighbor is not parent, okay, then I don't need to check. Okay, so if my neighbor node is not equal to parent node, okay, then in that case only we have to check for the things. Okay, so we have to check the sum, and how I'm going to check the sum plus, I'm going to call this DFS. Okay, same copy, same line. All right, now here my current node, so current node is going to become my neighbor node. Okay, so here just copy this, so my neighbor node, okay, I'm going to call the DFS on my neighbor node, and my parent, okay, now it is going to become my current node. Okay, so here just copy this, paste it here. Okay, and adjacency list, okay, we are passing the values. All right, and K, and the component count. all right. Okay, and here okay, so here we are going to call this sum plus this method. Okay, so after that just for some we can take this sum as sum modulus with k. Okay, so we can do this. Okay, and after that here this ends here. Okay, so here what we need to do, we have to do the calculate the sum with how I'm going to update them sum as sum plus equal to here values at the current node. Okay, values at the current node. Okay, so current node whatever the value we have. Okay, all right. Okay, and now after that here we have to update my sum as I'm updating my sum as sum of modulus equal to k only, right? And if my sum becomes 0, okay, this is one base condition. If my sum becomes 0, then in that case only we have to increment the component count at 0 index plus plus. Okay, component count at 0 index plus plus. All right, and in the end we have to just return the sum. Okay, that's it, that's it, return sum. Okay, okay, so here 3. Okay, let's say k is 3. Okay, k is equal to 3, and we have values like this 9 uh, plus you can say 17. Okay, 9 plus 17, and this is nothing but 26. Okay, and let's say we have 4 here. Okay, so here what is output you are going to get 17 plus 4 21, 21 plus 9 30. Okay, 30, and if you divide this 30 with 3, you will get the remainder as 0. Okay, 30 modulus with 3. Okay, so this is one thing. Okay, you can also write it like this now, 9 modulus with 3. Okay, plus 17 modulus with 3 plus 4 modulus with 3. Okay, so you are going to get the output as 0 here. Here you are going to get 3 5 is 15, so remainder is 2, and here you are going to get 3 1 3, so here remainder is 1. Okay, so summation is 3. So here you can also do it like this. Okay, so that's why we are writing like this. Okay, so sum is equal to sum modulus with k. That's why I'm doing it. Okay, that's why I'm doing it. Okay, so that we are going to get the lower value only. Okay, in case of any large value we can just keep it small as possible. Okay, and this is how we are going to calculate this. Okay, initially I'm taking the sum as 0 now. So in sum as 0, so here I am at here, so here I'm adding sum is equal to sum plus value at this particular node. Okay, so 1, so I'm adding 1 here. Okay, and I'm checking if sum becomes 0. Okay, then I'm incrementing the count. Okay, so let's run it and see if the code issue will try to fix that. So the test case has been accepted. Okay, so now let's submit it. So see, our solution is accepted, right? And it beats 100% of users with Java. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.